Hello everyone, welcome back. Today we are going to solve a very interesting question from Leetcode called 3Sum. The question is very straightforward. We have an array of n integers and we need to find all unique triplets such that the sum of each triplet is 0. Understood? Let's see an example. The array contains -1, 0, 1, 2, -1 and -4. We need to return a list of all triplets which gives sum of 0. So we can have -1, 0 and 1. We also have another triplet which is -1, 2 and -1. So we are going to return an array that contains these triplets. And that's it. Like always, there is a brute force approach where you can generate all triplets whose time complexity would be n cubed, where n is the number of elements in the array. Why? See, we need to create a triplet out of n integers, which means we need to pick 3 numbers out of these n integers. So for the first number, we have n choices. For the second number, we have n minus 1 choices, because we cannot count same number twice. And for the last number, we have n minus 2 choices. In big O notation, the time complexity would be n cubed. Now, there is another way, which is better than the brute force approach. I'm not going to explain it, but I'll tell you the idea. What we can do is, we first sort the array, then we write two nested loops, each for the first and the second element of the triplet, say A and B. Then, instead of writing a third loop, we can perform a binary search on the remaining array. Therefore, the time complexity of such solution would be n square log n, because we replace the third loop with a binary search. Alright, so now we are going to discuss an approach which is going to work within the time limits. But first, I want you to understand a simpler version of this problem. Let's say we have an array. We need to find all unique pairs whose sum is k. So what we can do is, we first sort the input. You will know in a moment why. Then we are going to implement toPointer method to find out the pair. We place pointers on the corner of the sorted input, and then we calculate their sum. We compare this sum with k. If sum is less than k, it means we need to increase the sum. We can say that in order to increase the sum, we need to increase the numbers that made up this sum. That's why we sorted the input array in the first place, so that if we need a larger number, we can go right, or if we need a smaller number, we go left. So if the calculated sum is less than k, we will increase the left pointer by 1. Similarly, if the sum of values at two pointers is greater than k, we will decrease the right pointer by 1. And if the sum is equal to k, we can update either both or any one of the pointers. Let us see how this approach would work with an example. We have the array and we need to find all unique pairs having sum -2. So we first sort the array and then we put pointers on the leftmost and the rightmost element of the array. In this case, the pointers are being represented by the corners of a window. So we have -4 and 2. The sum is -2. In the very first step, we find a pair. Now because we have found a pair, so we can update either left pointer or the right pointer. Let's say we update the left pointer. Now we have -1 and 2. Their sum is -1. -1 is greater than -2. So we need to reduce our sum. That's why we need to update the right pointer. The sum would now be -1 plus 1, that is 0, which is still greater than -2. So we need to decrease the sum. That's why we need to update the right pointer. Now, the sum is -1. -1 is still greater than -2. That's why we need to further reduce the sum. We move right pointer towards left. Now we have -1 and -1. -1 plus -1 equals to -2. We have found another pair. And that's it. Because we have visited every element, we can't go further. We are now going to implement a similar kind of technique for our main problem. The only extra thing we need to do is, for every element A, we need to find all unique pairs having sum equals to -A. Let's see our final algorithm. So first, we sort the input array. Then for every element of the sorted array, implement toSum as discussed with sum equals to minus nums I. After implementing two sums, update the pointer I if nums I equals to nums I minus 1 to avoid duplicate triplets. It means for any given I, you have already generated triplets. And whenever you find a valid triplets before updating j or k, you must also ensure that you do not generate duplicate triplets. Let us now see the code. We first sort the array, then we create an empty array to store the triplets. After that, for each I from 0 to length minus 2, we first check if the value at I is same as that of I minus 1. It means we have already considered the triplet starting from nums I. Then we initialize the left and the right pointer as discussed. After that, we just implement toSum. If we find a triplet whose sum is less than 0, then we update the left pointer. And if we find a triplet whose sum is greater than 0, then we update the value of our right pointer. Otherwise, when we find a triplet having sum of 0, we first store it into an array, and after that, we can either update the left pointer or the right pointer. It's up to you. But you need to make sure that the new value of left pointer or the right pointer is different than before to avoid duplicacy. At last, we return the list of triplets. So that's it for today's video. If you like this video, please hit the like button and subscribe to my channel.